our next question is about a nuclear reaction which is between two deuterium molecules forming a helium molecule. This is a simple question of nuclear physics. Okay, they had given you that the output power required is 200 megawatts and the efficiency of the reactor is 25%. That means the reactor must be producing 200, but it must be using more than that. So 75% of the energy is getting wasted. Now let's just start. So if I am seeing the mass defect in this problem, the mass defect is the mass of the reactants, that is 2 into 0.41 minus the mass of the products. Remember, reactants, the mass will be always greater. This is less mass because the defect of the mass, extra mass, goes into energy. This comes out to be 0.0256 AMU. Okay, so this is my mass defect. This mass defect converts into energy using Einstein equation, and this gives me 0.0256. Because it is an AMU, I am using C square as 931 mega electron volts per AMU. Okay, so this answer gives me something. I'm just leaving it right now. So now 25% of this entire energy will be how much? So energy used per fusion. So this is a single fusion reaction. So per fusion would be 25 by 100 into 0.0256. Remember, whenever you have larger calculations, leave the calculations to the end so that your time would be saved. Okay, some things would just cancel on their own. So I'm just leaving it like this. Now, how much energy do I require per day? Remember, this is in mega electron volts. Okay, so my energy which is required per day is 200 megawatts. There is a difference in units, so you need to convert either into this into joules or this one into mega electron volts, right? So I'm just converting this megawatt. I am converting into just joules per second. So this would just be 200 into 24 into 60 into 60. Okay. Now per fission, how much mass we require for the deuterium is 2 into 2.041. So if I want to convert this into grams so that my answer would come into grams, it would just be mass of deuterium will be 4.0282 divided by Avogadro's number. This would give me approximately 0.6691 10 to the power minus 23 grams. So every fission reaction is requiring this much gram of the deuterium. Okay, so now let's just see how much deuterium would be required once we want the entire 200 watt. Okay, so this would be 0.69691 10 to the power minus 23. This is for one thing into now how much energy I want. 200 into 10 to the power 6 megawatt into 24 into 60 into 60 divided by, I had what? Here I have that energy per fusion. So this I need to divide it by. So just do this calculation. This is approximately giving me 9.5334 10 to the power minus 13 joules. Mega 10 to the power 6. Electron is 10 to the power minus 19. So this gives me this. So I'm just dividing this by per fission key energy required and energy of one fission. So this solving gives me 120 grams. Okay, that's it. Thank you. So my answer is mass is 120 grams.